This is the second part of Unit 5 for on more collisions. So what we're going to do is we're going to have a look through the example that I've got on the website. So if we go to that example, if we can find it, here we are. Then what we've got is a set of collision balls, and they've got some fire behaviour. So I can take one of the balls and I can fire it out there, and when it hits the other, we get a proper sort of collision behaviour. So not only are we detecting the collisions, but we're also implementing the dynamics which results when one ball collides into another. So if we look at the source in this example, then we've got two main chunks of source. One is the source for the actual component for the ball, and one is the source for the main application. So if I just expand the source tab here, you can see that there's the ball version 3.mxml, that's the ball component in itself, and then we've got the spark collision detection v01. So if we have a look at the ball component itself, then here we see that we have the code that we had for the previous ball, and we've got the usual initialization function here, which adds a couple of event listeners. One is which is the on enter frame one, which calculates the dynamics, and the other one which reacts to the mouse down event. So the first one, the one that does the on enter frame calculations, just calculates the new position from the updated velocity, and the updated velocity is updated from the acceleration, the AX and the AY that we have here. The AY that you'll notice is set to gravity, and the AX is set to 0. So we've just got a gentle acceleration due to gravity here. Then we have the fireball functions, and what these do is on mouse down, they will add a couple of event listeners. One which draws the red string, and the other which on release of the mouse actually puts the vector from the centre of the ball to the current mouse position as indicated by the red string, and it makes that the new velocity vector for the actual ball. So here we see the assignment to Vx and Vy for the red string. You'll also notice it's divided by 5, so we take the vector and we make it 5 times smaller, and that's our new velocity vector. And we remove the relevant event listeners which we've been using, and switch back to the normal dynamics events handler, and that's basically it. So now if we have a look at the parent MXML, then in here if we go to the bottom, you'll discover that we've just got some text. We've got a couple of buttons here which implements the about and the reset function, and we can go up to the top and we can see that we've got an initialization function which fires on creation complete. This initialization function is here, and what the initialization function does is it dynamically creates a set of balls which adds to the it adds these elements to the application. And for convenience, it also pushes them onto an array which I'm going to call ball X, and that's going to allow us easy access to these 10 balls in this case. The number of balls is set out here as n balls, and you'll see that it's initialized here to 10. Okay, so once we've set up the initialization, once we've done the initialization, we've randomized balls here, and that just randomizes the position and the velocity of each of the balls in turn. And now what will happen is we'll start to get the on enter frame functions being called. This one is called when we have a bounce off the wall. It detects the bounce off the wall and calls the relevant bounce function within that ball. And of course again it has to do that it has to iterate through all the balls that we've got here. We've also got a separate new function called detect collisions, and what this detect collisions does is it goes through each pair of balls and it does a collision test on each pair. And in the collision test, what we're going to do is we're going to use a hit test, and we take one ball, we use a hit test of that ball, and as an argument we use the other ball of the pair. And if that returns true, then we know that the bounding boxes are overlapping, and Then there's an extra bit of arithmetic here which just checks to see whether the two balls themselves are overlapping, and if that's true, then the function returns true. And on the return of true, then we get this second function here, implement collision, being called with the two balls which are called the collision. This time the arguments are called B0 and B1 for these two balls which are involved in a collision. And what happens here is we have essentially code very similar to Peter's, mainly taken from Peter's implementation of the collision. And what this does is, first of all, it calculates the angles and the sines and the cosses which are necessary to do a transformation. And what that transformation is going to do is it's going to rotate the two balls into the horizontal axis so that the velocities that we have to care about are only in the x direction. So what we do is we calculate the velocities in this new x dash direction, and once we've done that, we've incremented there, then we rotate everything back. We rotate both the velocities and the positions back, and that's basically the collision done. Once that's happened, then the balls will go on a new direction, and we can have a look at the application here. If we go back to the original Flash application, if I grab one of these balls and now I fire it, then we'll get collision reactions. This works effectively with, at the moment I've got 10 balls, it will work with 20 balls. By the time you get up to 40 balls, then the whole thing starts to slow down quite drastically, because it's got a lot of calculations to do in terms of detecting the collisions mainly. But for 10 or 20 balls it works fine, and that's the end of this section.